Okay, so a chi-square test of independence really tries to look at whether or not two variables are independent of each other. For instance, in our coin example here, the flips of the coin should be independent events. So knowing the outcome of one coin toss should not tell us anything about the second coin toss. Just because I go tails, 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 the next one I can't say, well, I'm due for a heads now. No, exactly 50-50 shot every time. Same thing for gender of a child, right? So you always look at that one family and they have like 7 boys and she's pregnant again. You think, oh my goodness, now you definitely have to get a girl. No, in fact, it's still a 50-50 shot. So each coin flip is an independent event. The chi-square test of independence essentially is a non-parametric version of that interaction term in ANOVA. If you think back to our analysis of variance chapter. So very few assumptions are still needed. For instance, we make no assumptions about the shape of the distribution. Again, the expected frequencies for each category should be at least 1, and no more than 20% of the category should have an expected frequency of less than 5. Now I know in this little experiment here, we're going to violate that assumption, but that's okay. With test for goodness of fit, we only have to have 1 variable, but for test for independence, we need to have at least 2 variables. Okay, so the chi-square test of independence is a component of the crosstabs command rather than the non-parametric statistics. So for this one, we're going to go up to Analyze, go down to Descriptive Statistics, and then go over to Crosstabs. Okay. Now our first one is going to be coin 1, and we're going to put that in the row. The second one is going to be coin 2, and we're going to put that in the column section. Go over and check on the statistics really quick. Yeah, so click on chi-square because we're running a chi-square analysis. We're not doing a correlation. And then go continue. Let me just double check. Yeah, so you can go expected if you want to. You don't have to for our one here. So you can leave it blank or not blank. And I'll click it just to. Right, it's just the observe versus, or the counts observed versus expected, and then go okay. Then you should get an output window. And here we have our case processing summary. We have the cross tabulation, so coin 1 versus coin 2. So you have here coin 1 heads and tails, and then up here coin 2 heads and tails. So if you kind of think about like a cross tab, this is what we call like a 2x2 table. 3 cells, right? 75% have an expected count less than 5, and we knew that. We knew that before we ran the analysis. And we can see here by our significance level that it's not atypical, right? We're not going to reject that null hypothesis. We failed to reject it. It's not significant. That p-value should be less than 0.05 if that was true. Our Pearson chi-square is, so if you want to think of like chi-square obtained, 0.737. And yes, I know, again, we have a little note down there that says that, well, you have one that has less than 5. So you would say, well, that the significant chi-square test results indicate the two variables are not independent, and a value that is not significant indicates that the variables do not vary significantly from the independence, or what we would expect to see in something like this. And that makes sense for coin 1 versus coin 2. If we're looking at things like hair color or eye color, then we're obviously going to see a little bit more variance. But for coins, that's okay. So for this second part of the lab, right, you should have coin 1, coin 2, run it like this first. Just make sure that all your numbers match mine. And then do your one that you saved as coin 3 and coin 4, the coins that you flipped, and send me a screenshot of that. Awesome.